Hey guys, how you doing? This is me here, Mr. Hawkins, and my daughter Taylor, and we're going to do a little thermochemistry action in the kitchen here. So we started thermochemistry. Hopefully, been working on that packet today that I assigned you and put on Power School. And so now we're going to do a little demo that will apply to what you just did today. All right. So here's what we got here. We got these two different square blocks. This we call block A, and this is block B. All right. So before we started this video, all right, my daughter wrote down descriptions of the two here. So we listed them here on the board here. Okay, block A, as you can see here. Say block A, Taylor said it felt kind of like a piece of metal and actually felt cold in her hands. And it was really, really heavy, felt pretty dense, and it was a very smooth texture. So that was block A. On the other hand, block B, well, when she was holding block B, it felt plastic. Right? So instead of metal, it felt more like a plastic block. And it was a very sandy, rough texture as opposed to the smooth one of block A. It also felt a lot lighter than block A. And when she was holding it, it felt more like room temperature feel. So block A felt colder than block B. Now, just to let you know, I've had these blocks at room temperature just sitting out here in the kitchen for a while here. So why one felt colder than the other, I don't know. Here I have a little infrared temperature gun. So the last piece of data we're going to do is we're going to take the temperature of these two. All right. Thank you, Chewbacca, for holding my board. All right. So block A. Remember, block A was the cold one. So I'm going to hold my temperature gun here. And it looks like we got it at 21.9 degrees Celsius. So we'll write that down, 21.9 degrees Celsius. All right. And the other block, remember it's the warmer block, 21.5 degrees Celsius. All right, so we're only off like 0.4 degrees Celsius. So that could be within range, say that they're pretty much the same temperature. Right? Now remember, we said this one felt cold and this one felt room temperature. But temperature-wise, they did look pretty much the same. Right? So now, what we're going to do is our next test here. Behind the child, aka Baby Yoda, we have two ice cubes. They're about the same size here. I just took them out of the Hawkins freezer. And now, these little rings, these are just to keep the ice cubes on. We're going to put one ice cube on each of the blocks, and then we're going to observe what happens as we put them on there. Okay, so Taylor's going to pick up the cubes, and on a countdown of 3, 2, 1, she's going to put them on the blocks. And I'm going to move the screen a little closer so you get a better view. Ready? 3, 2, 1. And I'm going to zoom up there, and let's see. All right, if you look closely, what do we got there? I know this is exciting. See? What's happening? I know, since they canceled baseball, now we're having ice cube melting races. Isn't that great? Thank goodness for COVID-19, right? Exactly. All right, what we got here? We're not going to do this all day, even though I know you want to. Maybe we'll do an extended version later. Who knows? All right, so we got block A, the metal block, the cold block, the heavy block, the smooth block. That ice cube's melting really, really fast. It's almost gone there. Okay, block B, the plastic one, the sandy feel, feeling light, room temperature feeling or warmer feeling. Not doing a darn thing. All right, so there you go. So, what's going on here? We have two blocks here. Okay, we got two blocks here. They're the same size. Okay, one's a little bit heavier than the other. They both color the same color. They're both started out the same temperature. This one was colder. All right. This one was colder. What makes things melt? Heat. Why does something feel cold make something melt so much faster than something that feels a little bit warmer that's not doing a darn thing? Something to think about here. All right, now we're going to take some temperatures again here. All right, so I'm going to take the temperature of block A. All right, I'm going to write this down too. All right, so I'm going to take the temperature of block A. And the temperature here is 13.9 degrees Celsius. So let's look at block B here. Take that temperature here. 20.9 degrees Celsius. So they both started at the same temperature. This one felt colder. Okay, this one felt, block A felt colder. All right. But now the temperature dropped. Let's back that up a little bit. Temperature dropped even more. Look at that big drop there. Okay. But wait a minute. You're supposed to add heat to melt the ice cube. What's going on here? All right. So all these weird questions I'm asking, your job to answer them. All right. So hold this here. So this is your job. This is your lab report here. Here are the directions. I'll be posting a link to upload this on PowerSchool very soon. So here are the directions. This is a lab report. So you're going to write it up like a usual lab report. You're going to write your name, date, title. Write out your data table. You just have one back there. Observations. So what did you see? What happened to block A? What happened to block B? And then your write-up, your conclusion, your descriptions. You're going to tell me what happened. What happened? What was going on here? So now you got to be scientific when you write this because you're all scientists. Here's some terms I want you to use. You can use some other thermochemistry scientific terms. I want to see at least these in here. Endothermic, exothermic, heat transfer, heat capacity. Now another term you can use for heat capacity you can substitute is something called specific heat. Right? Now when you use these words, I want to use them so I know that you know what they mean. Okay, don't just say this was endothermic, this was exothermic, period. Okay, tell me what the words mean. So I want to see those words in your explanation. It should be a decent looking explanation. And at the end, do a little sketch, do a little diagram of what happened on a molecular level. All right, I just want to show the heat transfer. So molecule-wise, heat energy-wise, transfer-wise, you know, what's happening. So sketch that. And of course, have fun when you're doing this. So that is the lab report. All right, and again, you have, all right, your link will be up soon. And this will be due Friday, let's say noon, so I can read them on Friday. Give me something to do over the weekend. All right, and that will be your lab report. That will be your thermochemistry lab. All right, and we are coming up to near the end of the year. Next week is really the last week of classes, so assignment-wise, I might give you one more. This might be the last one. We'll just kind of see what happens. Also double check, make sure you get everything else in. All right. And as a final treat, my daughter would like to introduce another member of our family. This is our dog, Luna. Everybody say hi, Luna. Oh, yes. Wonderful. She has my eyes. All right. So there you go. All right. Enjoy. Get to work. And we'll see you later. Bye, guys. And, oh, yeah. May the 4th be with you. You got Baby Yoda here and Chewbacca here. Celebrate Star Wars. So once you get this done, go watch Star Wars on Disney Plus tonight. All right. See you later. Bye.